The trend is to blend specialty oils, even for high mileage applications like our Nissan. To check out how this is done, we headed to Kentucky, home of the Valvoline facilities.
They developed the first motor oil, the first multi-viscosity oil, and the first racing oil, all designed to solve different problems.
Today, with 6 out of 10 cars having 75,000 miles or more, the challenge is designing one for high mileage engines. To make that happen, oil engineers have a lot of ingredients to consider.
He has to select what types of base oils, what types of detergents, dispersants, antioxidants, anti-wear agents, friction modifiers, a whole array of different components that have different functions.
As prototypes are blended, a team of chemical engineers subject them to a battery of punishing tests. Boundary friction, cold cranking levels, viscosity flow, high and low shear, pumping rates, pour points, spectrographic analysis, and heat loss.
This is an ASTM D58 evaporation loss test, and we use it for max life to determine the evaporation loss in engine lubricants.
And just when you think this lab testing can't get tougher, it does. Valvoline is the only oil company with its own engine test facility that can qualify passenger car oils.
Whether it's oil for air and liquid-cooled motorcycles or marine testing for Coast Guard patrol boats, nothing gets approved without passing some extreme and unique engine tests.
Adam Swartz dyno test competitor oils on an Acura RSXS Turbo. At just 3,500 RPM and only 4 pounds of boost, the 1,300-degree EGT, the oil coked, wiping out the turbine bearing.
Tim Caudill studies the effect of high-mileage oil on fuel economy using chassis dynos and a pair of ex-Michigan police cars 24/7. These 4.6-liter Crown Vic Interceptors burn through thousands of gallons of gas, testing max life formulations looking for improved fuel economy.
Currently, they're probably up in the 160s, 170,000 mile range.
Designing the world's first high-mileage oil took 2 years.
We took older cars, older engines. We inspected older engines to see what they needed. They needed seal swell. They needed improvements in oil consumption. They needed deposit removal. We formulated that to meet those needs.
While the American Petroleum Institute created the test to beat the oil, these guys formulate oils to beat the test.
The engine facility runs around the clock, administering punishing ASTM tests. Everything from low-temperature cam wear, hot and cold sludge tests, valve seal testing, and viscosity tests.
And after all that testing, this is where we break down the engines and analyze the results.
Parts do fail, but most survive for detailed analysis.
This is what the piston looks like before we put it in the engine. This is what one looks like after 100 hours of running.
The brutal and expensive G3 piston test costs $45,000 to run each time. It measures a different oil for varnish blow-by. It takes a skilled eye to measure 20 different oils day in and day out.
Now, this is what we're looking for. When the oil's right, you have very little deposits.
A Sequence 8 test uses this special one-cylinder engine to test different oils for rod bearing wear.
This is the rod out of that engine. We're going to measure it for bearing weight loss.
After 40 hours at 3,150 RPM, Dave Caproni uses a digital scale to determine exactly how many milligrams of bearing wear occurs with each oil tested. These tests may be constant, but with engine technology changing constantly, formulating and testing newer, better specialty oils is a never-ending process.
It's exactly like painting the Golden Gate Bridge. Once you're finished, you go back to the other end and start over again.